Alright, ladies and gentlemen, welcome to Forces 2, Lesson 4.2, and this is how do you calculate pressure. We talked about pressure as in the outward push of gas or liquid molecules, anything that is in a fluid, and so we're going to be talking about how can we calculate that today. Basically, what we're going to be using to describe pressure is this device called a piston, and what it basically does is that it pushes fluids into a confined space, and it creates pressure as a result. And so you're looking at an example right here where you see the piston is this object here, the blue piston is right here, and the more force we push down in a given area, we are going to see a change in this pressure here. And so, as a result, if I look at this, to calculate pressure, you divide the amount of force applied to it by the area over which it acts. And so, over the surface, or over the area of the piston. And so, basically, our formula is this. If we look right down here, our formula is pressure equals force divided by the area. So it takes whatever force you put it into and it divides it by the area of the piston. And so over a large area, it's going to take a lot of force to push down that object, to push down that piston. Another way of thinking about it too is that it might also take less time depending on the pressure of it. And so it might require less force the greater the area. And so we're going to be looking at those relationships with this too. But basically, my unit that I use, since we have force in newtons, and our area is going to be in centimeters squared, we have newtons centimeters squared. Okay, so an example, this pump is pushing with a force of 70 newtons of force. So I'm thinking about this guy right here. And the surface area of the piston of the pump is 2 centimeters squared. And so I take my 70 newtons divided by the area of 2 centimeters squared, and I'm left with 35 newton centimeters squared. So here are some examples of this formula at work where we have pressure equals force divided by the area. And so our example here, for example 1, the area of the piston is 8 centimeters squared. The force of the piston is pushing down at a force of 160 newtons of force. What is the pressure of the gases inside the container? So I need to remember, well, what is my force? It is 160 newtons. And so I'm going to write an F right there for force. And then my area is A. And so I need to figure out what my pressure is. So I'm going to put those in, and I'm going to get 160 divided by 8 is going to give me my pressure. And so what I end up with is 160 divided by 8. That's going to give me 20, and it's Newton slash, because it's a division problem that we see right here, newtons centimeters squared. I use my Newton label, my force label, and then I use my area label as well. So we end up getting 20 newtons centimeters squared of force, of a pressure. So example 2, we're going to take a look at this, and we're going to see, okay, we have 2 of the 3 variables. How do I figure out what the third variable is? So I'm going to erase this example here. We're going to read example 2. The pressure of the container is 80 newton centimeters squared. The area of the piston is 5 centimeters squared. What is the force exerted on the container? So I'm looking at, this is my area. This is my pressure. So we end up getting P equals FA. Let's put the stuff in. 80 equals my force divided by 5. So to figure out what F is, I need to multiply both sides by 5. And that's going to give me 80 times 5 equals force. Which is going to equal 400 newtons of force. Okay, so in a way what that's telling me is that if I have the pressure of 80 newtons on this, of this piston, and the area of this is 5 square centimeters, that means it is requiring a force of 400 newtons to maintain that. And so I have a force of 400 newtons pushing both upward and downward on the piston. So that can tell us that we can get a lot of power into something if we change the pressure as well. So that's how we use the forces formula to calculate pressure. Our next video is lesson 4.3, how do I apply these ideas into different devices to do work for us.